So everybody has 4 parts, like a plug, the board, a little board, and a servo motor. Yeah? All good? So. Yes? And yeah, the plug. It's okay. You have the plug, you have your cable, so it's okay. Je peux démarrer, c'est bon? So. The small? Sorry, what?
They don't have.
Ah, okay. Okay. But you have a pie also? No, it's it's for you. It's for all of you.
Oh, it's for.
Because you only one board for.
We 4 share this.
Yes. Okay. Yes. All you have to plug with the Raspberry after.
Okay.
We'll explain. Ah non, c'était eux. Non, il manque une borne. No, it miss something. Il leur manque une plaque. Ah, mais on a distribué celle-là? Ah non, c'est moi qui l'ai prise. Mais il y a dessus. Attends, regarde, on va faire un trick. Tac.
C'est celui qui était
C'était eux là-bas. Tiens, tu peux donner ça aussi à ceux d'à côté, ouais. En fait, il y a la board, il y a que ça. Ouais, en fait, il y en a un autre. Regarde, on peut plugger ça. En fait, on peut plugger ça.
C'est vrai?
Bah, tu prends pas la lime? Ah non. Non, tu prends pas la lime.
Donc ça c'est bon?
Ouais. Ah bon? J'en ai retrouvé 2 là au fond là.
Ah, c'est bon?
Mais là je crois que.
Bon, là c'est pas grave, on l'a donc ça bien.
Ouais.
Ça sera.
Ouais, ce sera extra. Okay, sorry for the delay. So welcome to the Android Things workshop. To introduce ourselves, I'm Romain Menetrier. This is Gautier Mechling. You saw him before at the conference, I hope. And there's a missing guy, Eyal, who gives the workshop before with us, but he's in another conference in parallel now. So he can't be here today, but... And just to introduce, we like to thank Google because they pay for all the boards we have here. So thanks to them for providing us this. You have a link for the slide, this presentation, if you want, but I will come back later with this link. So I go quickly because we have usually we make this workshop in 3 hours. Today we have 2 hours and few minutes, so I will be quick. What we'll do today, we'll learn a little bit of electronics. I don't know if you know electronics, but you need some notion of it before going to Android Things. Discover quickly what is the environment of Android Things. And finally, just have fun and experiment with deadly weapons or toys, it depends. What is Android Things? So, are you experienced in Android? Who has already developed in Android? Here. Android? Yeah, Android, yeah. So, quite everybody. With Android Things? Yeah, one guy, okay. So a perfect fit for this workshop. What is Android Things? Android Things run a family of Android products. You know Android for phones, Android for Android Wear, Android TV, Android Auto, and now it's joining with Android Things. It targets IoT applications. So it's not meant for a small project. It's first project we need some quite of computations on the edge. So before going to the cloud, have some something locally. There's some example of things that can be done with Android things. So the easy part is if you know Android, like you, it's the same SDK. So it's Android SDK, so you know every libraries and every tools you use already. It's good for Android things. So Android Studio, and you have also Play Services from Google. And with Google Play Services, you have also a Firebase and cloud platform. So if you want to use like machine learning, like Gautier told you before, you can use it, Firebase, and a lot of things. This is the stack of all Android. And for Android things, it's quite the same, but some parts missing. It's all about phone part, of course, because there's no phone in Android things, and contacts, calendar, browser. And a few things about UI also, because the UI is quite different. In Android things, displays are optional. So you can plug a screens, but it can work also with alternative UI, like sound or just arrow key, yeah, or button. With Android things, it comes with IoT Developer Console, so it's a web interface to manage your IoT. There's automatic security updates, so if times there's something Google applied to the system, it's automatically pushed to your IoT. The images are signed, so it's very important because you put your application before deploying it, so it's secure by Google, by Android also. And you have a verified boot. Like this, it protects also, so you can't break your device. So in the stack, so managed by Google, as I say, there's a kernel, of course, the hardware libraries, the Android framework, like in phones, and you manage apps, and you manage also other drivers. I will come back later on these things, but it's to communicate, briefly, it's to communicate with hardware. For hardware kits, so there was Intel, but maybe you heard that Intel has discontinued its hardware line for Android things. But you NXP and the main things, if you don't want to choose, just choose Raspberry Pi. It works for a lot of things. So let's start by electronics. I will go very quickly just to show you some notion. The units. You have electric potential, within volt, the intensity of current, as ampere, and the impedance with ohm. And from this, you have three laws which with this, you manage a lot of things. The first, or maybe we can check it later because we must go quick today. Do you know these laws and these units? Yes? No, not really. So I will just get quickly on this. The first is Ohm law. He said that's just voltage, so tension in volt is impedance multiplied by intensity. You will show it, it's very useful. The second law, it's Courant's law. It's when you take 1 point, the current with an input, it's equal to the current of input. So it's useful also to calculate things in circuits. And the last is when you have a closed circuit, the sum of all potentials, it's always 0. But I will let you go further if you want to more explanation of this. I will go further on this. You can check the slide later. It's used to. I can explain you quickly. Also, when you have inputs to a logic circuit, you have on, you have off. So on is maximum voltage, so 5 volts here. Off is ground. And sometimes you have something which between. You have a floating point. You want to eliminate this because it's not good to have a deterministic state. So what do you want? It's what you can do. It's just plug a resistor, and you can like this protect the low and the high level. So I go quickly, but you can check this. It's very useful also. On electronic components, you have families of electronic components you can play with on droidthings, with electronics in general. The analogic part, with like resistance, diode, and so little lights and so on. The interface part, when you can display something, make buzzer, make sound, or people can play with their fingers, like switch, potentiometer, and so on. And you have sensors. Sensors are all about measuring temperature, light, and take photos, and so on. For today, we will limit to some things. So we have a Raspberry Pi. We have the Rainbow Hat. Rainbow Hat, it's a board with many sensors and things on it. So you have a temperature sensor, you have a 4-digit display, you have the 3 button, you say I, A, B, C. There's also pressure, light strip also on the top, a pressure sensor, I think I'm all set. And today we'll also play with a servo motor, with basically a motor who can just put an angle on an arm. So, one more Android thing, it's about specific APIs for Android things. So, as I said, it's the same as Android APIs, the same toolbox, with even ADB and so on. But you must forget some things. Common intents, like view a map or take a pictures, of course, it doesn't work. Content providers, many content providers like calendar, contacts, telephony, download manager, and so on, doesn't work on Android things. And also some Google services, like AdMob, app indexing, Firebase authentication, and play games, and a lot of things. But you can imagine that play games is not fitting very well with IoT project. But there are some new APIs, like peripheral I/O and user drivers. Peripheral I/O. It's about APIs to communicate from your code to sensors plugged to your board. There are several protocols available to communicate. How many of you have been to the conference of Gautier this morning? Okay, not all, but quite good. So you have talked about I2C, GPIO. We'll make a talk again about this. So to show you on the board, there's black pins. You can see there's a plan of these pins, and every pins have a special purpose, special way to communicate. There's some power pins, but also power dedicated to a specific protocol, like you see GPIO, UART, and so on. First, we'll explain some of the simplest way to communicate with this thing. First, it's GPIO. GPIO is the simplest mode. You have each pin. It can be a one input or one output. Can be the both. You have to choose between the two, and you have two possible values: high and low, basically. So you use it for buttons. You use it for LEDs and so on. Everything with a binary state. The second way of communicate, it's PWM. It's a pulse width modulation. It's also one pin, only output, but it can trigger a lot of values. So it's useful with motors, dimmable light, like you can be variable in intensity, and this kind of things. And the third family, the rest is about the family of the serial communications. When you need a lot of bandwidth on a single bus, so you can have many devices on the same bus. So it's very dedicated to complex peripherals, like a graphical display. Gautier mentioned it this morning also on NFC shields and this kind of things. So this thing is to resume these three families. And again, this page, now you see these protocols in the pin map. So to put it on the stack, peripheral law is about low-level communications. On top of this, there's the user drivers. So user drivers use peripheral I/O to communicate with a real device to enable portability, reuse, and integration also. So if you need maybe to have the position of a board, you need to combine GPS and gyroscope and many sensors to have this kind of things. So it can be on user driver level. So to show you how to bootstrap an app for IoT, for Android things, you had first to add the dependency. So the dependency is just this line, and you're all set for the dependencies. And you have to declare a special intent filter with a IoT launcher. IoT launcher, it's dedicated to IoT, to Android things, because you can't easily start the application, so it has to start with the boot. So with IoT launcher, it starts when the board starts. To show you an interaction with a device, here if you want to plug to a GPIO, so the more simple way to interact with, just have to get this. So you have to get the peripheral manager service, of course. Open a GPIO, so just give the number of the pin, like you see on the pin map on the Raspberry Pi I showed you before. If it's GPIO number 1, you have to put 1 here. You get the direction, because it can be input or output for a GPIO, so you have to set the direction. And trigger T, because you can trigger it, but you will use edge falling most of the time. And after this, when you want to get the callback about this, when you want to see when the GPIO is high or low, you have to register this callback, and just it's classical stuff on Android. So I think you know it. For input drivers, when you want to use it, you have to I don't remember. Yeah.
Actually, this you will not need today. It's for example, if I have a keyboard, and it's a very complex keyboard, and this keyboard, you will create a driver to interact with this keyboard, but when you press a button, events will not be transmitted to the Android SDK. So you cannot override on key down or on key up, because because the Android framework cannot know that you have on custom components, and these components cannot send events to the Android SDK. So if you override on key up, you cannot interact with your own custom component. So if you want to interact with a custom component and forward events from your user driver to the Android framework, you have to create stuff like input drivers or specific drivers like that. So it's very specific. If you have like a GPS, you bought a GPS board, and if you want to use a fuse location manager to receive events from your own custom GPS, you have to use like user space driver. So later on, when you will see the slides, if you want to see how a user space driver is made and how you create one, you can refer to those slides later. But you don't worry, even for complex stuff like electronics, even to me, I don't understand everything so far. So you will not need that, but it's still always good to be curious and to know about that.
Okay, thanks, Gautier, because I was lost in the presentation, but yes, that's it. Yeah. So, but useful part is when you want to use a library, because there's a lot of things developed by Google or by contributors, by community. So for many electronic parts, components, you have user libraries you can use to interact with. So like this for the button, you just have to use a driver like this. Just declare the driver and just set up like this. This is register for the space, and it's when low, so it's low states, and you have just to specify the GPIO pin name, and you're all set. Of course, you have to unregister it when you don't use it, and register when you start the application. It's because when you have many applications, you just lock the peripheral. So if you want to play nice with other applications on your device, you have to release and register and unregister it. So I go quickly on this. Let's get started with the workshop. I explain you the main component we will use today, and we will build a catapult. This is a deadly weapon we will use. So you have the Raspberry Pi. It's a development board. You all have plugged the USB, so it's okay. And you will use ADB for Wi-Fi. So when you plug when you power on your board, you have an ID just on the Ethernet port. You will see there's a number. So if you want to connect to your board, you put ADB connect things, and just with your ID close to things. Okay. Yes, the network. You must plug with your PC to something's PC. I will give. Yeah, we will explain you later this kind of things. Don't worry, we'll say it again later. So already I told you about the shield. We have many sensors and buzzer and LEDs and so on. We'll can play with. And the servo motor. See, it's very common one. Very cheap to buy if you want to play with it. It's very cheap. And the interface, it's pulse width modulations. You have to plug 3 pins. When you take the connector, you will see by the color, the yellow one is data, so it's a pulse width modulations port. The red, it's power supplies, and the marron, brown, thank you, is the ground. So it works like this. You have when you vary the frequency of the modulations, it gives an angle to the servo motor. So if with 1 millisecond, it's minus 45 degrees, and with 2 millisecond, it's plus 45 degrees. I will not explain you how it works behind, but it works. So you have the catapult? Okay. So we have the catapults. Où ça? Je vois. Ah, yes. There's a catapult here, so you have to take one also, one of it, not now, but just after. And it takes approximately 40 minutes to build, but we already built some of them. I hope there's enough. Yeah, there are only 10. So you have to share something. And if you want to find all the README to get the instruction for building all the stuff and get the catapult working, you can go to this link. There's all I explain you, like the Wi-Fi network, all the way to connect to ADB, and so on. So first, you have to go to this link to get. Quoi? Ah, yes, it's a GitHub project, so you have to clone it on your laptop. So I let you play with this. Please ask questions to us. We stay on the room, so if you have difficulties, okay?